Okay, so in this problem we are asked what is the solubility of lanthanum 3 iodate in water, and we're given the KSP for that compound. So first of all, let's write out the reaction that occurs when it does dissolve in water. Okay, so this is a solid, and it's what we would label as insoluble, and we know that because we are given the KSP and it's a really small number. But we also know that these things that we label as insoluble do dissolve a little bit, and when they do, they're just going to break apart into the component ions, which in this case would be the lanthanum 3+ aqueous, and then 3 iodate, IO3- aqueous. Okay, that would be the reaction that occurs. And the other important thing that we can write out about this is the expression for the KSP. I have the value of the KSP, but we're going to need the expression for the KSP. So just like every other equilibrium constant expression, it's just going to be the products of the products over reactants where coefficients become exponents, and we leave out solids and pure liquids. So the concentration of La3+ times the concentration of IO3- cubed, and then all of that would be over 1 because the reactant is a is a solid. Okay, so we don't know what the solubility is, but we do know the KSP, and we're going to use the KSP and this reaction to set up a table, okay, to solve this problem. Make our rows and our columns. So for the reaction, every compound gets a column. So that salt dissolves in a reversible way to form the component ions. Okay, and these two guys get a column. And I'm going to not do anything with the column for the pure solid because it doesn't show up in the expression for KSP. And then initially, like I said, the initial conditions would be 0 and 0 because we're going to assume that it's that moment in time before anything dissolves. But then when it starts to dissolve, we know that we're going to lose X amount of the solid, and we're going to gain, in this case, X amount of the La3+, and we're going to gain 3X amount of the IO3-, the iodate, because for every one of these that I dissolve, I form one of these, but I form 3 of these. And so then we just bring our columns down, okay? And now we can substitute that into the expression for the KSP. So the KSP would be equal to the concentration of La3+, which is going to be X, times the concentration of IO3-, which is 3X, quantity cubed. Okay? So we multiply all that out, and you get 27x to the 4th, and that's equal to the KSP that we are given, 7.5 times 10 to the -12. So then we're just going to plug that into our calculator. We're going to solve for x. Okay, and if you do, you find that x is equal to 7.3 times 10 to the -4. All right, and that is a molarity because if you go back up here and look, X is the amount of this compound that dissolves, so that is the solubility.